Okay, the first thing we should do is try to redraw this circuit into something that looks simpler. So you know there's a 12 volts potential here and a 0 volts potential here. So you know that current will be pushed from here to here. So you should imagine how a current would run from this point to this point. So one possible path is to go from here to here. Nothing can flow through the voltmeter, huh? So one path is to go from here to here. Let's call this resistor A and this B. So let's try to redraw the circuit here. So we must start from 12 volt and we'll end off at 0 volt. So one possible path is to go through A and then B, and then we arrive at the 0 volt point here. Of course, there's another path, which is this. So this is a path that's parallel to the original path. So in this path, we have C and D in series, because I must go through C before I go through D, before I come to the 0 volt point. So that's a parallel branch here, that's C and D. And what is this voltmeter connected to? It's connected to the far end of A and the far end of C. So the far end of A and the far end of C. So this is where the voltmeter lies. Alright. So what would this voltmeter measure? Okay, to get that, actually it's easier if we imagine that the voltmeter is not connected yet. So without the voltmeter, it should be quite clear to you that we are going to have a PD of 6 volts across A and 6 volts across B. Similarly, you get 6 volts across C and 6 volts across D. But what is important is that you should realize the potential at this point here should be 6 volts. Likewise, the potential here should be 6 volts, because it's 0 volts here, right? And then there's a potential difference of 6 volts, so it's 6 volt potential here and also here. This means these 2 points are at the same potential. So if you put a voltmeter here, you measure the potential difference, right? Which is 6 volt minus 6 volt, so 0 volt, because there's no potential difference between these 2 points. Okay, that's it. Ta-ta.